గుడ్ మార్నింగ్ స్టూడెంట్స్. ఈరోజు మనకు టాపిక్ ఏంటంటే స్టాక్. సో వాట్ ఈజ్ స్టాక్? ఆల్రెడీ మనం డేటా స్ట్రక్చర్స్ డిస్కస్ చేసినప్పుడు చెప్పుకున్నాము. సో డేటా స్ట్రక్చర్ ఈజ్ ఏ కలెక్షన్ ఆఫ్ డేటా which can be organized in a efficient manner so that whenever we want the data we can use the data efficiently, right? So data structure is classified into two types. So one is linear and second one is non-linear data structure. Okay, so as we have seen in the class, examples of linear data structure, that is array, and second one is stack and queue and linked list. So already we have seen about array and linked list. So array, what is meant by array and types of arrays, and linked list and types of linked list. So in this unit we will see about stack and what is a stack, and about the implementation of stack, and what is queue and what is the implementation, how to implement the queue, right? Today's class we will see what is stack and what are the operations that you are going to perform on stack, right? So as you know, stack is a linear data structure. Stack is a linear data structure in which insertions, that means addition of elements, you can use the word here, insertions or additions, insertion of elements or deletion of elements, okay, and deletion of elements will be done at only one end, that is called as top of the stack. Students, stack is a linear data structure in which insertions and deletions will be done at only one end, that is called as top of the stack, right? So for example, stack of books. Okay, so this is a empty stack. Okay, I am adding here one element, it is 10. Okay, so if you want to insert any elements into the stack, first of all you have to create a stack. Okay, next, and I am inserting one more element, 20. So before inserting the 20, so here the top portion will be here, and after inserting this the top portion will be here, and next 30, and this is 40. So always we have to insert the elements only from the top of the stack. Okay, so initially the top variable will be assigned to -1. Top is equal to -1. Whenever you are incrementing the values, whenever you are inserting the values, the top variable will be get incremented by 1, that is top plus plus. So here initially the top value is 0, index portion of the top value is 0, and when you are inserting the value here, you are going to increment the top value, that is 1, and one more value, top plus plus, and again here one more value, top plus plus, that is 3. So here remember one thing here, whenever you are inserting the values into the stack, the top value will be incremented by 1, and when you are deleting the elements from the stack, the top value will be decremented by 1, right? So here, as I already told, whenever you are inserting elements or deleting elements from any data structure, so what you have to check is you have to check where the condition is empty. The condition is empty, you have to check the empty condition. Here also, whenever you are inserting elements into the stack, you have to check the condition, that is overflow condition. So whenever you are inserting elements, you have to check this condition, that is called as overflow condition. Overflow condition means whenever already you have filled the elements with the stack. That means here, for example, if I take a stack of size 4, okay, already you have inserted all the elements into the stack. Now you are trying to insert one more element into the stack. Is it possible? No. So the best example is we have eaten idlis. Okay, already we have eaten 10 idlis. So but if you want to insert, if you want to eat one more idli, can we eat? No. So how much idlis our we can digest? That many number of idlis only you can eat. Similarly here, top of the stack, we cannot insert one more element. That condition is called as overflow condition. Okay, whenever you are inserting any more element, you have to check the condition, that is called as overflow. For example, water bottle. So water bottle is with full of water. So if you want to pour some more water into the water bottle, is it possible? No. That condition is called as overflow conditions. Already the stack is full. You are inserting one more element, but it is not possible. That is condition is called as overflow condition, right? And when you are deleting elements from the stack, you have to check the condition. That condition is called as underflow condition. So underflow condition means, best example is there is an empty water bottle. So you have poured all the water, poured out all the water from the bottle. So still you are trying to pour out the water from the bottle. So is there any water in the bottle? No. So similarly here is already the stack is empty. Already the stack is empty. But you are trying to delete elements from the stack. So is it possible? No. So that condition is called as underflow condition. So these are the two conditions you have to check whenever you are inserting elements into the stack, and when you are deleting elements from the stack. You have to check these two conditions. That is called as overflow conditions and underflow conditions, right? Now we will see what are the operations that you are going to perform on the stack. So that is push operation. Push means inserting elements, and pop operation, you are deleting elements from the stack. So similarly you will perform the operation called as display elements. What are the elements in the stack? So these are the three operations that you are going to perform in the stack: push operation, pop operation, and display operation, right? Here remember one thing, here always the top variable will be assigned to -1. So whenever you are inserting elements into the stack, the top value will get incremented by 1, and when you are deleting elements from the stack, the top value will be decremented by 1, right? Here we will see one example, and I am trying to push elements into the stack. So here I am trying, this is a stack, right? Here now the stack is empty, and now the top variable is assigned to -1, right? Now I am inserting the value 10 into the stack. So stack of size 3, right? Here the top value will get included by 1, it is top plus plus. So top plus plus means -1 plus 1, that is here 0. So that is called as top of the stack. Next I am inserting one more element, that is 20. So now this is 0. Now the top value included by 1, that is top plus plus. Here now the top portion will be here, that is 20. And next okay, now 20, I am inserting one more element, 30, and that is top of the stack. Here will be this. Similarly in the same way, so that is 0, 1 and 2. Now in the same way, if you want to delete the elements from the stack, you have to delete elements from the top of the stack only, right? And here now you have to decrement the top value by 1, right? That means top value, now the first 30 will be deleted. And next, so you can see in the diagram, so now our stack contains how many elements? Our stack contains 3 elements. So what are the 3 elements? 10, 20, 30, right? 10, 20, 30. So the index positions are 0, 1, 2. Okay, right. Now I want to delete elements from the stack. So from where you have to delete? You have to delete from the top of the stack. That is 10, 20. Okay. Now I am deleting 30 element. So now top portion will be decremented by 1. That is here the top portion will be here. Next I am deleting one more element. So now I am deleting 20. Now the top portion will be here. Now I am deleting the last element also, that is 10. So now the stack is empty. Now you can't delete any more element from the stack. Now the stack is under flow. Okay, so here you have to check the two conditions here. What two conditions means? Stack is overflow or not. Overflow means, if you take for example the top the size variable size, okay, so the condition is top is equal to size minus 1. Size minus means here we are taking 3 minus 1. So if top is equal to 2, that means here this condition. this condition. Already top is equal to size is minus 1. So already the stack is full. You can't insert any more elements into the stack. That is called as overflow condition. Now you have to check that is underflow condition. Top is equal to minus 1 because here already elements are deleted. So top is 0. Okay. Okay. Now decrement the stack, that is top is equal to minus 1. Here top value 2, 1, 0. Okay. Right. Top decremented by 1 and top decremented by 1, it becomes 0. Again top decremented by 0, that is top is equal to minus 1. So whenever the top value is equal to minus 1, you can't delete any more elements from the stack. The stack is already empty, right? Now we will see the algorithms for push operation and pop operation and display using the operations push, pop and display, right? Now you have to create an empty stack for this. So already we have seen in the linked list concept. So before you are going to create any insert in any node into the list, what you have to do is you have to create a node. Similarly, now you have to create a stack. So here stack can be implemented by using array and as well as linked list. But here by using, what is the disadvantage of array? You have to predefine the size of the array when you are going to declare an array. So one more important point you have to remember here, that is stack will follow which principle? The stack will follow last in first. This is the important point. Last in first out. Stack will follow last in first out. So what is the last element here that I inserted? Here the last element that I inserted is 30. And what is the element that I removed from the stack? That is 30. Last in first out. Remember, don't get confused between stack and queue. So the stack will follow LIFO principle. The last in first out. Right? Now we will see the step-by-step operations for stack. Okay. In search, first what you have to do is you have to create a empty stack, right? So same as when you are doing a C program, what you will do, you will include all the header files as include stdio.h as include. So include all the header files and declare one array of stack, that is int stack of what is called, this is a size of the array. So you can define the size of the array by using as define constant. Okay, first as define size 10. That means into the we can create a stack of with the 10 values, right? So now we have created a one-dimensional array, and you have to create one more variable here. That means that is top is equal to minus 1. That means the stack is empty, right? And now you can use the insertion of push for pushing the elements. You can call the function called push, and for pop operation you can call pop. And if you want to delete the elements, you can display the elements. You can use the operation that is called as display, right? These are all the necessary things whenever you are going to insert elements into the stack. So push operator, you have to create a stack into stack of size, and you can predefine the size as define size of 10, and you need one more variable, that is top is equal to minus 1, and you can call the functions which are necessary, that is push operation, pop operation and display operation, right? Now we will see the stack. Push, what is the first operation? Push operation, right? Push. So here push a function will take one value, so push of value. So you are inserting 10 value into the stack. So before going to insert the value into the stack, what you have to do is you have to check the condition that is called as overflow condition. So what is the overflow condition here? Top is equal to size minus 1. So already I have told. So here the type of size of stack is 3 and 3 minus 1. So top is equal to 2. So here the next position, if you start the next position from 0, 0, 1, 2, and the top will be indicated to 2. So you have to check the condition overflow. So, and you have to check the condition, and you have to, the condition is true, so you have to display a message. So insertion is not possible. Why? Because already the stack is full. Class lo మనం 100 మెంబర్స్ కూర్చోడానికి సీటింగ్ కెపాసిటీ చేసాము. సో 100 మెంబర్స్ వచ్చి ఎక్కడ కూర్చుంటారు, కూర్చోలేరు, కాబట్టి ఇట్ ఇస్ కాల్డ్ as overflow condition. Right. Next, step 3. So you have to check if here the condition is false. Now what you have to do is you have to increment the top variable by 1. Top plus plus. Top plus plus. And you have to push the value like this. So stack of top is equal to value. Why? Because in the stack, so variable the value inserted at the top post position. So now you are using like this, stack of top is equal to value. Right. So we have still see how we'll see one. So check the condition whether stack is empty or not. And next, if display a message if the stack is full, insertion is not possible. And now if the condition is false, increment the top variable by 1 and use this as a assignment like this. Set stack of top is equal to value. Why? Because where you are inserting the value at the topmost portion, that is we are using like this, stack of top is equal to value. Right. Now the last operation, the second operation is pop operation. So pop operation will not take any parameter. Pop function, not pop function will not take any parameter, but here push function will take a parameter, push of value. You are inserting value in the stack. Here also you have to check the condition. What is the first condition to be checked? Whether the stack is empty or not. So what is the stack? What is the condition here? Top is equal to -1. Right? Top is equal to -1. Now, so display a message. Deletion is not possible. Why? Because deletion is not possible. Now here the stack is empty. Okay. Stack is empty. So deletion is not possible. Right. Next, what you have to do? Decrement the top value by 1. Decrement the top value by 1 and top value by 1. And what you have to do is you have to, whenever you are deleting element from the stack, what will happen is the top portion will be decremented, and to the next element the top portion should be assigned. So you have to assign like stack of and assign stack of top to the next value. So like this. Here. So now you are deleting element like this, deleting element 30, and the top portion will be decremented by 1, and top portion will be assigned like this. So for this assignment we are using this stack of top. So this is the pop operation for stack. So did you take an example? Already we have discussed. So but we will see step by step. So 10, 20 and 30, and this is top of top. So index positions are 0, 1, 2. Right, clear? And now you are deleting element that is 30. So here 20 and 10. This is the topmost position, and the index positions 0, 1. Top is assigned to 1. Now delete the element 10, that is top. Again here delete the element. Now again delete the element. So here the top value is assigned to 0, and again if you decrement this, top is equal to -1. That is top is equal to -1. Now you can't delete any more element from the stack. Right. Now the last operation is display operation. So before going to perform display operation also, you have to check the condition whether the stack is empty or not. So if the stack is empty, so what elements you will display? So you will not display any more elements from the stack. Right. You have to check the condition. So first step 1, you have to check the empty condition. So empty condition means that is top is equal to -1. Remember here this is called as empty condition for stack. So when coming to linked list, where there you use the concept head is equal to null, that is the empty condition here. So in this step top is equal to -1. So if the stack is empty, display an error some message. So stack is empty, and you can terminate the function. Now coming to step 3. So if it is not empty, you have to display the elements from the from the stack, that is for example 10, 20 and 30. So first what you will do, you will display 30, you will display. So for displaying the elements, you have taken a variable I, okay, and you have to assign this variable to top, right, and display stack of I value, stack of I. So this is 2, 1, 0. So stack of 2 means 30, right, and next decrement the value. So here you already displayed this element, and now decrement the top value, that is 1, and next what is stack of 1, 20, and next this element is displayed, and next last, that is stack of 0, 10. So you have to decrement the value to -1, okay, right. So what you have to take here, logic, I is equal to top, I greater than or equal to 0, and I minus minus, and display stack of I value, right. Okay, now the elements will be displayed. So this is a text, this is a stack. Now 30, 20 and 10 will be displayed. So this is the display operation. Okay, thank you students. So listen carefully to the videos, and if you have any doubts, you can revert back to my WhatsApp number, and CRs, be responsible how many are listening to the videos, and the students should send attendance to the CR, right. Thank you.